Lesson 8.1c, count outcomes. So yesterday we have done finding the sample space, the total number of outcomes of events, where we had to draw a large tree diagram. Those can become very cumbersome and take up a lot of space. Well, there is a way to figure out total number of outcomes without doing any of that. And it's something called the fundamental counting principle. So if an event M can occur in M ways, followed by another event N occurring N ways, then the total number of ways that can happen is M times N. Now, what that means is how many possible or things can happen or choices first times how many possible choices second, and so on. You multiply the number of possibility or choices together. Look at that first example. Andy has 5 shirts, 3 pairs of pants, and 6 pairs of socks. How many different outfits can Andy choose with 1 shirt, 1 pair of pants, and 1 pair of socks? So you need to set this up for a multiplication problem, and I would definitely label each choice. So we've got shirts, pants, socks. How many shirts? 5. How many different pants? 3. How many different pairs of socks? 6. And you simply multiply 5 times 3 times 6, you get 90 different outfits. 90 different outfits. Okay, I will. All right, 90 different outfits. And I'll be honest, if I was going somewhere, I don't think changing the socks would change my outfit, but according to this, it does. Okay, so yeah, I probably would say maybe I'd only do the shirts and the pants. I'm not sure that I really consider the socks changing it, but you never know. Anyway, the whole point of this is you're multiplying all the choices together. Caden? That's all we're doing. That's all we're doing. Okay, so now let's check this out. I'm going to do several examples with you before you get started so that you understand what you're supposed to do. Please write these down. I don't want you to miss anything. It says, use the fundamental counting principle to find the total number of outcomes in each situation. We are rolling 2 number cubes. So remember me talking yesterday or whatever day it was this week about how die or dice, they call them number cubes now. There's 6 sides and all that. Okay, so to do this problem, here's kind of how I would set it up. I would say cube 1 and cube 2. There's 2 different things going on here. If I rolled that first one, how many different things could come up? 6. If I rolled that second one, how many different things? 6. So how many different things could happen? 36 outcomes. And I would go ahead and label these outcomes unless it says something else. 36 outcomes. Number 2, tossing 3 coins. Tossing 3 coins. So I'm going to have coin 1, coin 2, and coin 3. How many things can happen, Caden, from coin 1? 2. How many different things can happen with coin 2? 2. How many different things can happen with coin 3? 2. 2 times 2 times 2. Be careful. How much?
Exponents.
Yeah, what is it?
It's 8.
8 outcomes. 8 outcomes, not 6. 8 outcomes. Number 3, picking 1 consonant from the 21 consonants and then picking 1 vowel from the 5 vowels. So we're going to pick a consonant and we're going to pick a vowel. So how many different consonants could I pick from? 21. How many different vowels can I pick from?
5.
So 21 times 5, how many combinations? 105 outcomes.
Could we do this thing on our paper if we understood it?
Okay, look at number 4. You're choosing. It's like looks like you must be buying a computer or something. 1 of 3 processor speeds, 2 sizes of memory, 4 sizes of hard drive. So I need to pick a processor. Oh, nope. Let's do it this way. I need to pick a speed, a memory, a hard drive. How many different speeds, Dylan?
I was going to say the answer.
Okay, you can say the answer in a minute. How many different speeds?
3.
3. How many sizes of memory?
2.
How many sizes of hard drive?
4.
Okay, multiply all that together.
4.
24 outcomes. Okay, I want to do one like number 5 especially because it looks, all those numbers might look tricky, but I can choose between a 4, 6, or 8 cylinder engine, and I can choose between 2-wheel or 4-wheel drive. So I'm choosing the cylinder and I'm choosing the drive. How many different cylinders do I have to choose from?
3.
Caden?
3.
3. How many different types of drive do I have, Caden?
2.
2. How many different choices of car or vehicle?
6.
There's 6 outcomes. Okay, number 6, 2 number cubes and 2 coins. Be careful. 2 number cubes and 2 coins. I'm going to go this route. Number cube 1, number cube 2, coin 1, and coin 2. How many different outcomes from that first number cube? 6. How many from the second one?
6.
What about that first coin?
2.
What about that second coin? Okay, so what's it going to be? 36 times 4. What are we thinking? 144 outcomes. You want to know how I did that? Check this out. What if you multiplied 6 times 2?
30.
12, and then 6 times 2 again. So 12 times 12, that's where I got 144. Okay, let's move this up. Let's do number 7, and then we'll finish up here with number 7. Choosing a color from 4 colors, and then a whole number from 4 to 10. So the color, and then the number. So how many colors does it say? 4. Now, how many whole numbers are there from 4 to 10?
7.
How can there be different? 4 to 10. 4, 5, 6, 7, 8, 9, 10. How many are there?
7.
Look at the screen.
5, 6, 7.
4 starts with the first one, so there's 7. So how many altogether? How many? 28 outcomes. Are there any questions? Any questions? All righty.